Welcome to Beneath the Surface, where we delve into the stories and insights of those shaping our built environment. If you're passionate about geotechnical engineering, seismic resilience, and the challenges of large scale infrastructure projects, hit that subscribe button. Stay updated with expert interviews and real world engineering tales. Today, we're joined by Matthew Marcus, Managing Director at Partner Engineering and Science Inc., with over 25 years' experience spanning commercial, industrial, public sector projects. Matthew brings a wealth of knowledge in geotechnical investigations, seismic risk assessment, and multidisciplinary project management. Matthew, welcome to the show.
Hi, thank you for having me.
No, more than welcome. I was wondering if you can just take us through some of your educational background and early career experiences to set us off.
Sure. I started engineering in college. I didn't really know what I wanted to study after my freshman year. I knew I was going to do something in science. And back in the old days, they had literally a book of all the majors at University of Arizona, and and I looked through it, and I thought, I ended up with doing a degree in geological engineering, and I like hiking. I love the outdoors. I grew up in Phoenix, Arizona, so I just really enjoyed the outdoors, a lot of hiking, biking out in the desert, and I like math. Was always really good at math and physics. So I thought, geological engineering, perfect. I can be outside. I can solve math problems and, maybe get paid down the road. And so that was it. And it was a really nice department. I graduated the Department of Mines, Geologic Engineering and Mining at University of Arizona, 1999. And started working for a firm doing geotechnical engineering in 2000. I did have some offers to go work for some mining companies overseas that paid a lot more money, maybe 3 times more money, to actually be a geological engineer instead of a geotechnical engineer. But I would have had to move to Malaysia, and I thought my mom might have a heart attack if I did that. And also I had met my wife, so I decided, we weren't married, but I thought it was pretty special, and I wanted to stick around. So I stayed in Tucson. And worked for a local firm called Western Technologies for a couple of years. Did a lot of work for master plan kind of residential subdivisions, city streets, utility lines, a lot of like kind of greenfield development or, unfortunately, one of the things I didn't like about it was that they were developing a lot of raw desert land into subdivisions, which was hard for me as someone who liked to hike and mountain bike in those areas to see it, being bulldozed. But that was a job. I got to go out to some interesting places. I learned a ton. And this was back in the day before cell phones and things like that. So, well, I mean, I started off, I got a pager. And so if we had a problem on a job, we'd go, have to go find a gas station and call the engineer and page him, and then he would call you back. And so you really had to figure things out. Back then in the field, as a young field engineer, I think maybe to some degrees, having everything, all the plans and all the project documents and aerial photos and a GPS unit and a camera, in your phone, it makes the work a lot more efficient, but it also reduces the amount of time you have to spend on preparing for a site visit, making sure you have all the driving directions, making sure you have all the equipment you're going to need and all the paperwork. And then also creative thinking and problem solving on your own, not just always calling back to headquarters to get direction. So I think I benefited a lot from that. But I also, I maybe was just lucky in where I was, born. We also did, we were using Microsoft Word, Microsoft Excel, emails in the school environment in the 90s already. So I kind of had a little bit of a leg up on some of the other engineers. When I started working at Western Technologies, they were using Word Perfect still to write reports, and they're printing them on those things with the little sprockets on the side. And, you had to peel them apart and all this. So
Really,
So,
they're really
most
now.
of most of the engineers that were working when I started, they didn't know how to use computers hardly at all. Um, and So that was really great. And there was one summer. It gets very hot in Arizona, as you know. And there was one summer, and my wife and I did end up getting married there. And so I decided I can't do this anymore, and I need to get out of Arizona. It's too hot, And it's not just that it's hot, but it's hot for like 6 months in a row. Very hot. So we decided to go get graduate degrees, and we went to North Carolina State University in Raleigh. She was studying entomology. I got into the civil engineering, and at that point, I knew I wanted to do civil geotech. So I got into a straight, civil geotechnical degree, master's degree program with a focus on construction. I worked for a local company out there, kind of a regional company, Froling and Robertson, as a project manager. The boss, at least in my estimation, was very hard on me. I mean, they let me attend school, but they did not let me. I had to make up those hours, So, I mean, I was working very hard, 10, 12 hours a day, dropping in and out to get to classes, um, and staying up, late into night to finish the labs. But again, a lot of residential subdivision work. We did some university work, some community college work. There were some greenfield developments, which again I didn't like, where they were knocking down a bunch of trees. But there were more infill jobs at that time. It was a little less heartbreaking. And then I finished up my degree there, got my license, and moved back to Arizona. But I guess that would be kind of my early career in a long, long roundabout way.
Great. Okay. So now you're in California.
Yes, now I'm in California.
So I was wondering if you could just tell us a bit about your, the understanding sort of seismic hazards, working on infrastructure projects, their impact on infrastructure projects.
Well, the most of the seismic issue is handled structurally. So the easiest way that I understand it is, buildings are really good. Like a conventional building is basically fighting, vertical loads of gravity. Maybe some wind, maybe some frost, maybe some snow. But like serious seismic loads are now suddenly yanking the building back and forth. And so where, to my understanding, where buildings fail is at the connections, historically where they failed is at the connections from the walls to the foundations, or from the columns to the roof. And so a lot of the seismic stuff is done by structural engineers to just make sure that those connections are right, so that when you get like a sudden yank, it doesn't just rip apart and the whole thing moves. And I mean, you get more complicated than that. Obviously, you can get harmonic shaking and things that problems that they've had before, like unreinforced masonry. It's like very brittle, and so it'll just crack and fall apart. I mean, they had historically, like a lot of brick chimneys would just like fall over, rip away from the house, fall over because it's just stacked bricks. I think they have a pretty good handle on it. In the geotech case, we do look at fault. We get involved in fault studies, fault surface rupture. We look at liquefaction hazards, which is where you've got kind of soft soils under a building that are below the groundwater table that can suffer from instantaneous strength loss, and that results in like settlement. There's lateral spreading, which is like that kind of the same concept, but on if you have a slope, then it could cause slope failures. So when we do slope stability analysis, we have to evaluate the factor of safety for seismic loads on the slopes. And we provide equations for the structural engineer for lateral loads on retaining walls as well. But mostly we're just, we're just like looking up the information more or less and then providing equations to the structural engineer. So nothing too fancy.
Struggling to find top geotechnical and geoenvironmental talent? You could use a generalist recruiter, or you could use a specialist. At Geo Expert Search, we place experts where they belong. Across the UK, USA, Australia, and New Zealand. No highways, no bridges, no structures. Just geotechnical and geoenvironmental. Now and forever. Geo Expert Search. Finding the right people for the right roles with no wasted time. Visit geoexpertsearch.com to learn more.
I was wondering if you can tell us a little bit in terms of strategies for assessing and mitigating the actual seismic risks.
Sure. Well, a lot of it, again, the mitigation is structural. If you have a fault line, I've heard that there are places where they've come up with a design to build on top of a fault line, but generally, most of the time, you offset 50 feet from where the actual fault line is. You can't build anything within 50 feet either side. For liquefaction, the most common thing that's done, if the liquefaction is minor, is we'll create kind of a rigid fill pad or use a rigid foundation so that, the differential settlement will be limited. We'll put in maybe like 5 feet of reinforced aggregate base with geogrid in it. And then we'll put a mat slab foundation on it. So, if you do have a big earthquake and you get like 3 inches of settlement on one side, the building will probably be okay, because with that rigid fill pad, instead of having 3 inches of differential settlement, maybe now you'll be down to 1.5, and a mat slab can easily withstand that. So, even if you end up with some cracks in the building or something, nobody's life safety is at risk, and it's not like the building's going to have to be ripped down or anything like that. So and then, the nuclear option for that is just drilled shafts, just taking deep foundations through the liquefiable layer, to something competent on the bottom, but that can be quite expensive.
Yeah. So is that the kind of case study for highlighting successful seismic retrofitting projects, which is the next question, of course?
Well, the retrofit, again, I mean, that's usually structural. So they will just go in and upgrade the connections and put in like moment frames or whatever. And sometimes those will require a new foundation, but it's usually nothing special, just like a little pad, and they'll put in like so if they like a soft story unit is a lot of times the problem. So they'll put in like a moment frame so instead of just having columns there, they'll put in like an X bracket, inside to just make it more stiff.
So you mentioned people would actually build on the fault line just a moment ago. Usually build 50 feet away. How would they manage to do that? And yeah, I wonder if you could just tell us a little bit about that. Do you know anything about
I'm
that?
not sure. I think that you would dig down and you would make a very thick foundation, I guess, so that
Yeah.
if the ground moved a foot on this side, your building would just be heavy enough to push through it. I don't know.
Oh, okay. I wonder if you could just tell us a bit about the importance of integrating geotechnical, civil, and structural engineering.
Well, it's really important. I mean, I think a lot of this stuff, I think a lot of the things, the problems, and I was literally just doing a call earlier today on risk in construction. A lot of the problems are exposed during construction, and it results in project delays and change orders. So a lot of the losses having to do with it are because the design is not consistent, right? The geotech, civil, structure, they aren't paying attention to what they're doing to the other one is doing. Maybe it is that like the geotech report was done 4 years ago and it didn't have the most up-to-date version or anything like that. But so, we've seen conditions where they've drawn up plans that have loads that exceed the loads that we anticipated in our report. In fact, we had one where it was in construction and it came out in the middle of construction that, they had designed building loads that were double what we used for our settlement calculations. And, we put our building loads, a lot of geotech engineers, they just put bearing capacity in. But that's like, the bearing capacity is only a very small part of the story, because the total load really matters a lot. And, so if you give them 2000 PSF bearing capacity, but then they want to put, 1,000 kips on it, they're going to end up with like a really big, really heavy footing. And if you only did like a 20-foot boring, there's no way you calculated the settlement on that. So, so a lot of times that gets missed, that the structural design's way above what we put. So we always give like our max column load, our max wall load, and then the allowable bearing pressure as well, to deal with that. So we've seen that come wrong. There's been a lot of cases where the infiltration system, a lot of the cities in the West, they won't let you drain into the storm sewer. They want you to hold the water on site, and they want you to infiltrate it into the ground. In the East Coast, though, a lot of times they don't want you to infiltrate it into the ground. They want you to release it in the stream, but just later. But and the ones where you are trying to infiltrate it, I mean, we've seen many, many cases where the storm drain system was designed based on a wild guess by the civil engineer, and they didn't know that we have testing that kind of makes their design impossible. And so then there's a scramble towards the end of the project to get more data and redesign the stormwater system. And so a lot of times that can be a problem.
So I was wondering if you could just give us a few kind of challenges and potential, or some solutions that you've come up with in managing large infrastructure projects throughout your career.
Well, I mean, a lot of it is really just dependent on the prime of the team, right? So, we can try to remind them to include us, and we try to push back. A lot of times they'll ask us to do something like an addendum or whatever, and I think maybe a lot of firms would just to get it done, they would just send them something and they wouldn't really look into it. But we really require that they send us the most up-to-date drawings and everything. Like anytime they ask us to do anything with the report, we will ask for the most current drawings, because I kind of like, my philosophy is the best thing is just to avoid the mistake rather than trying to worry about who you're going to blame later. Is just like, let's not have anything go wrong, and then you don't have to fight over whose fault it is.
Yeah, definitely. Have there been, so it's quite a litigious place and a litigious sort of industry, or can be. I presume that you must have been in several scenarios like that, where you'll get to feed the lawyers lots of nice fees to continue. In the insights into effective communication and collaboration in teams, what you just mentioned and sort of touching on there a moment ago, how important is that? Are there any instances where it hasn't quite worked? How did you get around that?
Well, I mean, my philosophy has been to, to try to resolve things without having to get lawyers involved. We've been very lucky, knock on wood, we haven't really been roped into any major lawsuits. Salt over the shoulder, knock on wood.
Yeah,
whatever you have.
You said it now.
But I mean, but there's been times where people have thought that some thing that came up during construction that should be a change condition could be our fault. We usually always have our point of view as to why it's not. Sometimes maybe we have made a mistake, but in any case, we try to hear out everybody's point of view, and we're really, we're here for the company's here for the long term. I mean, I care about my reputation, and so sometimes it doesn't even really matter if you did anything wrong or not. If the other person believes in their heart that you did, and you're just not willing to give them anything, that's, I don't agree with that. So, we usually try to just come to some sort of agreement, understanding that everyone can live with, and it's been pretty effective. throughout my career to just, be willing to work. My boss, the guy, Joe Duraki, the CEO here, he had a really good saying for me. He said that the most dangerous situation isn't one where you've made a mistake, because when you've made a mistake and you know you made a mistake, most people have no problem admitting it. Well, the problem is when you haven't made a mistake, but they think you made a mistake, your tendency is to always want to fight against the injustice of it all, But the reality is that it's probably not worth fighting. Most of the time, it's not worth fighting. And so far, that philosophy has steered me well.
Yeah, I suppose on the other side, I'm thinking of some experience or things I've heard, companies maybe not making so much profit out of a particular project, or maybe they've got into some kind of trouble and saying, actually, this is your fault. We're not going to pay for certain areas, and trying to kind of claw back some. I'm not sure if that ever happens or you've ever kind of been in that situation, but I know from experience of being in those rooms where those conversations had, and then they were, willing to do that essentially, where perhaps it wasn't quite the truth. It wasn't quite their fault, but it was a case of we haven't made enough, or we've made a loss, or whatever it was for them to do that.
Well, it's hard because the margins in this industry are really, really small. And so when you start thinking about, okay, well, it's $10,000 to make this problem go away, and if my profit margin is 10%, that's $100,000 worth of work. It's like, it's hard to just say, okay, well, I did $100,000 worth of work for free. But on the flip side, if you don't make it right, you could get sued. You'll almost certainly never work for that client again. And so, you just got to take your lumps. It's part of doing business, and, not try not to take it personally. Luckily, those things do come up. Luckily, they're not that frequent. And usually you come out on the other side with a bunch more projects and a stronger relationship with that client. It pays off in the end. So having a little humility and just, business, like thinking long-term about the business, I think is a good way to do it.
Yeah, I think that's important. That we kind of faced, obviously not any geotechnical rebate problems, but in kind of recruitment, if something goes wrong, which occasionally, of course, it does, and even though we might not agree, or actually is very clear in the contract in black and white, but long-term connections, long-term success in business is not fighting every single point every single time. So it's important to understand that as well.
Yeah, the older you get, the more, or at least for me, the more I realize that being right is not always that great of a place to be.
No, I'm still learning that. But yeah, you definitely don't need to be right all the time. It's really not worth the hassle sometimes of actually proving your case. By the time you finish proving your case, you're like, okay, well, I haven't actually won anything now, have I? So let's kind of move on. So I was wondering if you can just tell us a little bit about emerging technologies in geotechnical engineering, ground investigations, monitoring.
Sadly, I don't have much to say on that. I mean, we kind of have a very old school approach. I mean, we do have, we do use the rock science software. We have, we use Settle, but we also have kind of our own spreadsheets that we've made and developed that for maybe the smaller projects we use, just, like Excel, or maybe even some quick hand calculations. Yeah, I mean, there's been stuff that we've read about. I mean, I was really interested for a while in thermocouples for concrete testing. I don't know about the economics of it. I mean, I like it, and I have had projects where we've used it successfully. I think concrete testing maybe is just like the dumbest thing, and I guess I haven't seen a technology yet, but I really would like to have a better way of doing quality control on concrete. I don't know how familiar. I know it's concrete. It's not geotech, but most geotech labs do test concrete. We test a lot of concrete, and it's a hassle. You make the cylinders. They have to sit overnight undisturbed to cure, and then somebody has to go back and find them. And on a bigger job site, there might be multiple crews pouring concrete on the same day. So you got to make sure you find them, make sure you find the right ones, get them in the truck, transport them properly, um, strip them, label them, put them in a book, put them in a curing tank, break them, and then report at 7 days and report again at 20. I mean, it's like such a confusing, and then you throw all the concrete. You got to have a giant dumpster. It just seems so outdated, so outdated. So I'm hoping somebody, if anybody can create something to get rid of concrete cylinders, like the nuclear density gauge, but for concrete cylinders, man, that'd be something. Yeah, I wonder if you could run a nuke gauge on concrete. I'm gonna have to look into that. I'll call Troxler up. What if I do a backscatter on the concrete? That would be something for us. We're mostly working for commercial real estate projects. I mean, if somebody needs something really, really technical, we probably refer them out to somebody else. But for me, concrete, that's what anyone listening knows about that, call me.
Yeah, definitely. Give me a call, let you know if you can stop doing that at some point. What's your vision for the evolution of the field? Do you have one? Have you heard one?
Well, I don't know. I think that what we do will be difficult to replace with non-human labor. And I think it's also difficult to replace with human labor. I think there's just a lack of interest, and it kind of makes me a little sad. But I think there's a little bit of a lack of interest in what it is that we do. I think there's I think the thing that drives me nuts the most is that people think of engineering as not being creative. And I'm like, what do you think creative means? Because is it people that build things, people that make things? Because to me, that's pretty creative. I mean, making up a dance, okay. But building a building, building a street, building a bridge, that's creative. And so we're literally creating stuff. And, I do see a little bit of a trend. My son is in, I guess, Gen Alpha or whatever. And they seem to be having kind of a trend of back towards getting away so much from being on the internet and being outdoors more. Maybe it's just his friend group, but they seem to have a little bit more regard for the fact that working with your hands is not a bad thing. And you and I were kind of talking about this before. I mean, I got into this field because I loved the outdoors, and I found geology very, very interesting. And I still think that it is, and understanding those processes is key to being a good geotech engineer, because you know what you're looking for. But I also love problem solving and math. But I've spent a lot of time on construction sites, and I've spent a lot of time in the field, and I've gained an appreciation for seeing a project go from like a dream, right? Somebody's dream to build this thing. And then one day you're there eating dinner, or, staying at the hotel that you worked on, or flying out of the airport terminal that, you worked on, or driving over a bridge that you worked on. And I mean, and then you can annoy the crap out of your kids. Oh, I worked on that. I worked on that. I worked on that, but, and they never give you free stuff. It's like, hey, I worked on this Wendy's. Can I get a free?
We made it possible.
Yeah. I want a free, what do they call their shakes? I don't know. Smooth, Frosties, free Frosty, but no, never do. Actually, I've never worked on a Wendy's. That was a lie, but I have worked on other fast food places.
Maybe you should tell them you did. See if you can get one.
But yeah, then nobody gives you any credit. Nobody remembers you, of course. But anyways, so I don't know. I think my guess is, if I had to take a guess, that eventually in like 10 years, there's not going to be anybody left to do this work, and the salaries are probably going to explode. And then when people see how much money they can make, they'll start going to school to get degrees in it. And hopefully there will be enough of us left to like train the new generation.
Yeah, we see it from here as well. I see it from clients I work with in Australia. So certainly here, and I know over there in the USA, there seems to be less provision of kind of geotechnical courses. Over here, there certainly is. There's less courses at university. There's less A levels, which is once kids have done GCSEs, then they go on to further study. So there's less geological courses as well, which is odd because it's such an important thing for people to do, because it kind of facilitates civilization in a sense, and not in a real sense as well. But
I just believe that it'll self-correct, and
yeah,
I don't see the work going away. What we do is important. It affects insurance companies and banks and people with lots of money. It affects them in a big way. So I don't, I just, one thing that's interesting is you could look at a site, a site in town, and if the city kept all the records, you might see that site's been drilled by like 10. It's all the whole site is just geotech boring backfill. It's at some point. But the conditions 10 years ago might not be the same as they are now. The building that they want to build now is different than it was before. Modifications have been made to the site. So even if the site's been drilled 9 times, you still need new borings. You still need a new geotech report. And I've tried to train my team how to write geotech reports. It's a very non-linear process. It's not like I can give you a series of 10 steps that leads you to writing a good geotech report. It's like do step 1, 2, and 3. And then depending on that, you might have to go to step 1 again and try again, or you might have to go to step 8, or you might have to go to step Q. And it's just, I don't think that there would be a way to create a program that could do it based on data. And I don't think that there would be a way to interpret the soil without literally having someone look at it. I don't know. Maybe there will be some geophysical method that could do that in the future. I don't know. But I think at the end of the day, people are just going to want to know that somebody looked at the soil and came up with an effective interpretation, and that if it all goes wrong, they have insurance so that you can sue them.
Exactly. Difficult to do AI apart from the owners or robots or whatever. Maybe it will turn into something different in the future. Who knows? There'll be tweaks, of course, won't there? But who knows where it actually go. So, Matthew, thank you very much for sharing your insights and experience. For our listeners, remember that the strength of our infrastructure starts with the ground beneath us and engineers who understand it. Don't forget to like, comment, and subscribe for more stories of the world of geotechnical engineering. Matthew, thank you very much for your time.
Thank you.